What's up, Math Brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. Today's lesson is all about the process on how to determine the number of terms of an arithmetic sequence. But before that, let us be guided of our objectives for today. First is, to determine the number of terms of an arithmetic sequence, and last, solve word problems involving determining the number of terms of an arithmetic sequence. Okay, without further ado, let's now start our discussion, starting with a review on the definition and formula of arithmetic sequence. Before going to the main discussion, let us review first the definition of arithmetic sequence and its formula. What is an arithmetic sequence? An arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. This can be both increasing and decreasing depending on its common difference. In solving problems involving arithmetic sequence, we will be using this formula. A sub n is equal to a sub 1, plus the quantity of n minus 1, times d. Where a sub n is the last term of the sequence, a sub 1 is the first term, n, which is the total number of terms, and d is our common difference. I hope we are all clear with the definition and formula of the arithmetic sequence. This time, let us now consider the following examples for our lesson for today. Example number 1. How many terms are there in the given arithmetic sequence? 6, 13, 20, and so on up to 90. In solving this problem, we will be performing the three-way steps which we have discussed in our previous video on finding the missing term of an arithmetic sequence. Let us now start solving this one. First step, we need to determine the value of the common difference. Again, just simply take any number from the sequence except the first term and subtract it by the previous one. We have there, 20 minus the previous term, which is 13, and their difference is 7. Next, we have 13 minus 6 is equal also to 7. Therefore, the common difference is 7. Let us now continue with the second step of our solution for the first example. This time, we need to identify all the given values. Going back to our sequence, we have a sub n, or the last term, which is 90. Next, we have the first term, or the a sub 1, and that is 6. Lastly, the common difference, which is equal to 7, coming from our previous step. This time, for our final step, we will substitute all the given values to our formula and start solving. Substituting the given values to our formula, we now have 90 equals 6, plus the quantity of n minus 1, times 7. Next, we will subtract both sides by 6, or another way, transpose positive 6 to the opposite side. From positive, it will now become negative 6. So, we now have 90 minus 6 equals the quantity of n minus 1, times 7. Simplifying this, we can get 84 equals the quantity of n minus 1, times 7. Then, we will divide both sides by 7, which will lead to the cancellation of 7 in the right side of the equation. We now have 12 from 84 divided by 7 equals n minus 1. Next, we will add both sides by 1, or simply transpose negative 1 to the opposite side, which will give us 12 plus 1 equals n. Therefore, the number of terms in the given arithmetic sequence is 13. Is it understood? I hope it's yes. Let's now proceed to our second example. Determine the total number of terms in the arithmetic sequence, 107, 101, 95, and so on, up to negative 61. Following our three-way step, let us now determine our common difference with the following solutions. Starting with 95 minus 101 equals negative 6, and 101 minus 107 is also equal to negative 6. Therefore, our common difference is negative 6. Next, let us now identify all the given values. We have the first term, or the a sub 1, which is 107. Negative 61 is the a sub n, and lastly, the common difference, which is equal to negative 6. For the final step, substituting all the given values in our formula, we now have negative 61 equals to 107, plus the quantity of n minus 1, times negative 6. Next, we will subtract both sides by 107, for us to get the equation, -168, from adding both 61 and 107, since they are both negative numbers, equals the quantity of n-1, times -6. This time, we will divide both sides by -6, which will give us 28. The result when we divide -168 by -6, equals n-1. Adding both sides by 1, we now have 28 plus 1 equals n. Therefore, the number of terms in the given arithmetic sequence is 29. Are we all clear with this, Brainiacs? If yes, let us now move forward. This time, let's us ponder on this question. How can knowledge on finding the number of terms of an arithmetic sequence will help us analyze AMP, solve real-life problems and make our decisions? Let's go and see. For our application. After Crisley's knee surgery, his trainer tells him to return to his jogging program slowly. The trainer suggests that he jog for 6 minutes each day for the first week, then 12 minutes for the second week. Each week thereafter, he suggests that Crisley should increase the time by 6 minutes per day. How many weeks will it be before he is up to jogging 60 minutes per day? In solving this word problem, you can now use your newly learned knowledge on find the number of terms of an arithmetic sequence by applying our 3-way steps. Let's start, Brainiacs. For our solution, considering the arithmetic sequence, 6, 12, up to 60. We have to determine our common difference using the following solution. 12 minus 6 equals 6. Therefore, the common difference is 6. Next, we have the given values of 6, as our first term. A sub n is equal to 60. And the common difference is 6. Let's now proceed to our final step. Step number 3, substituting all our given values to the formula. We now have 60 equals 6, plus the quantity of n-1, times 6. Next, let us subtract both side by 6 or simply transpose 6 to the opposite sides, making it -6. Simplifying this, we can get 54 equals the quantity of n-1, times 6. Now, divide both sides by 6, which will give us 9, from 54 divided by 6, is equal to n-1. Adding both sides by 1, we now have 9 plus 1 equals n. Therefore, Crisley's jogging time will increase to 60 minutes per day on the 10th week. Finally, we have already knew how to determine the number of terms of a given arithmetic sequence and applied it in a real-life scenario. Finally, we are now done with our lesson for today. I hope that you have understood very well the 3-way steps on how to determine the number of terms of an arithmetic sequence. Good job, Brainiacs! Before ending this lesson, please take time to answer the 15-item test on my quizzes.com account which I have prepared for you to measure your previously learned understanding on how to determine the number of terms of an arithmetic sequence. How? Just click the link in the video description below. Enjoy, Brainiacs! This ends our lesson for today. Thanks for listening and see you on our next episode.